Also in cargo, you really only had to worry about the stage where the cargo vehicle approached the space station. In crew, you have to worry about ascent. You need to get ascent correct. You have to do the approach and docking or berthing to station, and then you have to do the undock and then also the reentry. So in the case of cargo, it's a smaller problem. It's only the on-orbit piece, and you have the ability, you can tolerate much higher risk overall to the system not operating. In crew, you cannot. You've got to cover all three phases, and the precision has to be there. So we need to be really clear that these processes we're describing for COTS and CRS work for COTS and CRS. They don't necessarily work for crew, and we have a different process for crew. And I also don't see failures as a totally bad thing. You know, we try up front to remove all the hazards and all the failure possibilities we absolutely can in a design. But there's always some unknown that sits out there that you don't really know about, that your design is susceptible to, that no matter how much insight, how much engineering, how much testing you've done, you will never disclose all of those true unknowns, because some of them only reveal themselves in the actual environment of flying through the atmosphere or re-entering or doing the actual performance in the environment. So flying more often, as we are with cargo, is allowing us to get insight into those unknowns, and that's a tremendous advantage to us. So by flying often and having cargo that we can tolerate an occasional loss allows us to be smarter, remove those unknowns, as well as improve the design as we continue to move forward. So I think we have a very robust system that's going to allow us to continue to keep improving these cargo systems, and then these cargo systems, if they carry forward into crew, which some of them will then be able to fly crew with a lower risk because we've had the ability to weed out and see the failures in the cargo version. And that occurs very much in the Russian system. When they're going to upgrade a system on the Soyuz crew vehicle, they will fly it at least 3 times on their Progress cargo vehicle before it shows up on the Soyuz crew vehicle. So that allows them to see those actual new designs, maybe a new computer. They actually see it in operation for 3 independent flights before it ever goes on a flight with a crew. So that gives them a tremendous chance to weed out those unknowns, to find out where software doesn't work in the vibration environment that's slightly different than it was in the test environment on the ground. It really helps them fly better. So this combination of using cargo, which can tolerate higher risk, and flying more often helps you actually have potentially a more robust and better crew process moving forward.